Hello boys, welcome to the fourth video of the remainder theorem. Remainder theorem. So straight going for the theorem, we will discuss an example, and through the example we will try to understand what is remainder theorem. Suppose we have a polynomial px is equals to x square plus 4x minus 7, and I am going to divide it by x minus 1, correct? So in the simple language, since we are going to divide this polynomial by another polynomial, correct? You are going to divide a polynomial by another polynomial. So divide it. This will be the divisor, and it is being divided by x minus 1. So it will be divided by x times x square minus x, sign changed, cancelled out, it becomes 5x minus 7 plus 5 times 5x minus 5, sign changed, cancelled out, minus 2. Can you see this? This is remainder, correct? We have divided a polynomial by another polynomial and we got the remainder, correct? Another, what was the condition for the divisibility of 15 by 7? Means when we will come to know that 15 can be divided by 7 or not. So in the junior classes, we must have learned that the divisor should be greater than or equal to, the dividend should be greater than or equal to divisor. This divisor should be greater or equal. Here the values are compared for the condition of divisibility. In case of polynomial, we don't have the values. See, this is like x square plus 4. Here it is dividend, here this is the dividend. Here this x minus 1 is divisor and here 7 is divisor. Here the condition for the division was the value of dividend should be greater than or equal to divisor. But here we don't have the values. Dividend is here, divisor is here. So instead of going for value that we don't have actually, this is the condition of division. Degree of dividend should be greater than or equal to degree of divisor. Here the condition was value of divisor should be greater than or equals to value of dividend should be greater than or equal to value of divisor. Here we are talking about the value of dividend. Here we are talking about degree of dividend. So the comparison will be on the same pattern, but here the values are working, here the degree is working. So when you are dividing a polynomial by another polynomial, we have a condition for division, and that condition is degree of dividend should be greater than or equal to degree of divisor. So here the degree of the divisor was 2, here the degree of dividend was 2, here the degree of divisor was 1. Since it is greater, it means it can be divided, and we have divided, we got the remainder. This is the method of finding, traditional method of finding the remainder. Correct? But remainder theorem gives us another method of finding the remainder. So remainder was minus 2. Taking another example, and two examples. Suppose we have x to the power 3 plus x square plus 4x minus 3 divided by x minus 1. So the long division method, x square times alright, change the sign, it will be 2x square plus 4x minus 3, it will be divided by 2x times 2x square minus 2x, change the sign, 6x minus 3, 6 times 6x minus 6, change the sign, and it is 3. Two things. Condition of the division. Degree of the divisor, again, degree of the dividend should be greater than the degree of divisor, and that is there. So I have done the division and division. After the division, we are getting the remainder. Correct? We have another method of finding the remainder, and that method is actually remainder method or remainder theorem actually. So what was the method? Method is here. Take the divisor. You are going to divide by x minus 1. So take the divisor and find the value of x from the divisor. Correct? And since we are going to divide this polynomial, we are giving the name as px, and replace all x by 1. X replaced by 1. So 1 cube, 1 square, 4 into 1 minus 3. 1 plus 1 plus 4 minus 3. 6 minus 3. This was the remainder. Here also we are getting the same number. So we got the remainder. But the method is different. And this is only remainder theorem. But one thing is missing. In the long division method, we got the quotient also. But here there is no quotient. So remainder method gives us a method of finding the remainder without getting the quotient. Correct? So what is actual statement of the remainder theorem? So the important role was of 1. So this one you have got from x minus 1. And x minus 1 was the divisor. Correct? So, see, I am just generalizing the statement. Suppose we are going to divide by x minus a. Correct? What was the method? The method says that put the divisor is equals to 0. You will get a particular value of a. And the same value will be substituted to the polynomial. See, earlier it was x replaced by 1. So it becomes p1. And here the p1 is equals to 3. So here pa will be the remainder. After simplification, whatever value you will get, that becomes the remainder. So two things, and the most important things which we will use in each and every question of the book. Value of the remainder and the symbol of the remainder. This is called symbol of the remainder. How you will create the symbol. P from polynomial, 1 the value of x obtained from the divisor. So both together will be p1. That is the symbol. After substituting the value of x as 1, the simplified value will be the real value of remainder. Here we are going to divide by x minus a. So we need to get the value of x, that is a. So p from polynomial and a in place of x. So pa becomes the symbol of remainder. Correct? And after substituting the value of x in the polynomial, this becomes the value of remainder. So value of remainder, symbol of remainder. Correct? So this is a remainder theorem. Alright? So value and symbol. Last example. Suppose you are dividing a polynomial by x minus 10. What will be the symbol? So dividing by x minus 10. So the value of x will be from here 10. Take p from the polynomial. 10 the value of x. This becomes the symbol of remainder. Value I don't know because that can be calculated. But here the important part is the symbol of the remainder. The value symbol of the remainder will be, suppose I am dividing a polynomial by x minus 1 by 2. What will be the remainder? What will be the symbol of the remainder? So we are dividing by x minus 2. The value of x will be 1 by 2. So the symbol will be p1 by 2. Correct? So this is remainder theorem, which will give you the value of remainder without using the long division method. Correct? Now, come to the factor theorem. Factor theorem, so very simple. Suppose we are dividing 15 by 2 7 times. What is the remainder? 1. The remainder is 1 means not 0. So do you think 15 is divisible by 2? No. Because, sir, remainder is not 0. It means when the remainder becomes 0, we conclude that it is a complete division. Complete division means remainder becomes 0. So you can say 2 is not a factor of 15. 2 is not a factor of 15 means since the value of remainder is not 0, so 2 is not a factor of 15. Suppose it is 14, so it will be 0. So it is actually 0. So 2 will be a factor. Means a number is a factor of a number. This we have to check. How to check? When the remainder is 0, it will be the factor. If the remainder is not 0, it is not a factor. So remainder will give you the idea of getting the factor. What is the idea? When the remainder becomes 0, you will get a factor. When the remainder is not 0, is not a factor. So that can be applied for the polynomial also. Suppose we have px as x square plus 5x minus 6. Correct? And we are going to divide it by x minus 2. So what will be the remainder? So first was, this is the divisor, put the divisor equals to 0, find the value of x. Now write down the symbol of the remainder. I told you, take the p from the polynomial and value of x over here. So this becomes the symbol of the remainder. Now get the actual value. So all x replaced by 2. So 2 square, 2 into 2 minus 6. Solve it. 4 plus 4 minus 6. Correct? Becomes 2. So what is the value of the remainder? 2. So conclusion is this: x minus 2 is not a factor of px. Correct? Since the remainder is not 0, x minus 2 is not a factor. Another example. Px is equals to x square minus 5x plus 6, and I am going to divide it by x minus 3. What will be the remainder? So to get the remainder, put the divisor equals to 0, find the value of it 2. So value of x is equals to 2. So the symbol of the remainder 2. Replace all x by 2. Sorry, x minus 3 was there, no? So all x replaced by 3. 3 square minus 5 into 3 plus 6. Solve it and you will get 0. So what is the value of the remainder? 0. So what will be the conclusion? Conclusion will be this, that x minus 3 is a factor of px. So getting the remainder will help you to recognize about the factor. So simple concept for whole chapter. When the remainder is 0, divisor will be the factor. When the remainder is not 0, divisor will not be the factor. The whole exercise is based on this concept. When the remainder is 0, divisor will be the factor, and when the remainder is not 0, divisor will not be the factor. That's all.